Hi students, a hearty welcome to today's chemistry session. In the previous session, we have learned how to write the formula of a mononuclear coordination compound. Today, in this session, we will see how to name a mononuclear coordination compound if its formula is given. To name any mononuclear coordination compound, we have to follow some rules recommended by Iupac. Let's see those rules in detail and try to apply it and try to give names to the given formulas. Well, here we have the first rule. To name a coordination compound, name the cation first and then the anion. Here you have an example. Look into the given coordination compound. K2ZnOH 4 times. You know that potassium that is present just before the coordination entity, that is a counter ion. And you also know that it is a cation. How do you know that it is a cation? We have two options. One thing, if a counter ion is written before the coordination entity, that means it is a cation. If a counter ion is written after the coordination entity, that means it is an anion. Another option, you can just sum up the charges and you can identify. You see here, ZnOH 4 times. Here the central metal atom is Zn. Its oxidation state is 2+. And hydroxyl ligand is also present. Each hydroxyl ligand will have 1- charge. Here we have 4 hydroxyl ligands. So the charge will be 4-. So 4- plus 2+, you will get 2-. So the charge on the coordination entity is 2-. That means the coordination entity is anion. So then the counter ion will be naturally a cation. That is one thing. Another thing, you can easily understand that K, potassium, is having +1 charge. You know that. It's carrying a plus charge. That means it's a cation. So these are all the ways which you can use simply to find out which is the cation. So what is next you have to do? Take and write the cation first. Name the cation first. So you see the name here. Potassium is written first. Since it is a counter ion, you can leave a little space and then you can start with the name of the coordination entity. Tetrahydroxidozincate. Why it's written as zincate? Because it is negative. Coordination entity is anion. So the suffix ate is added. So zincate. And since the oxidation state of zinc is 2, we will write in Roman numeral that 2. So the name of the given coordination compound is potassium tetrahydroxidozincate 2 or potassium tetrahydroxozincate 2. Both are correct. Now we have the second rule. Name the ligands first and then the metal in naming a complex ion or a neutral complex. For example, we have the coordination compound NiCO 4 times here. Here metal is nickel, Ni, and the ligand is carbonyl, that is CO. So which one we should write first? The ligand should be written first and then the metal with its oxidation state. So we have 4 carbonyl here. So tetracarbonyl nickel 0, because 0 is the oxidation state of nickel in tetracarbonyl nickel. And we have the third rule. Names of the anionic ligands end in O. We'll see the example, then it will be clear for you. Neutral and cationic ligands are specified by their usual names. But except in the case of water. Water we won't write water, but we will write aqua. NH3, we will write amine instead of ammonia. CO, we will write carbonyl instead of carbon monoxide. NO, we will write as nitrosyl. And the fourth rule is containing 3 sub-rules. You can see here, to indicate the number of the individual ligands in the coordination entity, use prefixes mono, di, tri, tetra, etc. So it's going to be easy for you to use it whenever it is needed. When the names of ligands include a numerical prefix, the ligand to which they refer being placed in parenthesis. That I will explain with an example right now. The next sub-rule is list ligands in alphabetical order and ignore prefixes in determining the order. When you consider the alphabetical order of the ligands, you need not to consider whether it is di, tri or tetra or bis, all these things. That I will explain with the example now. To make the fourth rule more clear, I will give you an example. Here you have a coordination compound NiCl2PPH3 twice. Here you know Ni is nickel, Cl is chlorido, the ligand, and then PPH3, that is triphenyl phosphine, that is also a ligand. And here we have two Cl ligands, so we can write it as dichlorido. You know that 2 means dichlorido. And then here PPH3, that is kept in parenthesis, you know that. In that case, triphenyl phosphine, we will not use, that is also 2 in number, but we will, instead of writing di, we will use the term bis here. So bis, tris, tetrakis. These are the prefixes we have to use whenever a ligand is given in parenthesis with 2 or 3 in number, we use. If it is 2, instead of di, we use bis. If it is 3, instead of tri, we use tris. In the same way, here we have bis triphenyl phosphine. And the next thing is, according to the rule, we have to arrange the ligands just after the metal ion in the alphabetical order. When we arrange these ligands in the alphabetical order, we need not to consider the prefixes like di, bis, tri, tris, etc. All these prefixes are not considered when we arrange the ligands in the alphabetical order. Instead, we consider only the first letter of that particular name of that particular ligand. Here you can see chlorido is the name of the ligand, so C is considered. Triphenyl phosphine is the name of that particular ligand, so T is considered. So C, dichlorido comes first, then triphenyl phosphine. Okay, that is the order. So the name of the compound will become dichlorido bis triphenyl phosphine nickel 2. That is the name of the given coordination compound. Fifth rule, use a Roman numeral in parenthesis immediately following the name of the central metal to indicate the oxidation state of the metal. For example, we have a coordination compound AgNH3 twice plus here. Here in this compound, the oxidation state of silver is +1. So we will write diamine silver 1 ion. Here we have our sixth rule. In the sixth rule also we have sub-rules. So we will see the first sub-rule. The metal is named same as the element if the complex ion is a cation. Cation means if the given compound is having or carrying a positive charge, what we shall do? The name of the central metal ion will be given just as its name as an element. Like here Ag we have, so we will write silver. That is its name as an element. So we will use the same if the given complex is a cation. Now we have the next sub-rule. When the complex ion is an anion, the name of the metal ends with the suffix 8 that we have already discussed once. Let's see the example. FeCN6 3 minus. So what is the charge on the given compound? Negative charge. So the coordination entity is anion. So in that case, what we have to do? The central metal ion, name of the central metal ion will be written ending with a suffix. What is the suffix? 8, ATE. So here we have the name for the given compound, hexacyanoferrate 3 anion. So metal ends with the suffix 8. Moving to the next sub-rule, when the complex molecule is neutral, name it as name is given to complex cation, the normal way. For example, we can see FeCO5, that should be kept in square bracket. So how should we name it? Just like as we name the complex cation, pentacarbonyl iron, 0. 0 is given because iron is having the oxidation state 0 in this case. That we will study in detail when we discuss about metal carbonyls. Now let's see a few examples how to name a coordination compound. If a formula is given, We will do more examples in the coming sessions. We'll start with a few examples, simple examples. Let's write IUPAC name of the given coordination compound. FeC2O4 thrice 3 minus. This is the given coordination compound. The first thing we have to do is to identify or to sort out the central metal ion in the given coordination compound, that is iron. Iron is the central metal ion present in this particular coordination compound. So next is to find out or calculate the oxidation state of central metal ion. In order to find out the oxidation state of central metal ion, we should know the charge that is on each ligand. Here we have only one ligand, and that is oxalate. So here this oxalate, each oxalate ligand is carrying a 2 minus charge. And when we look into this overall coordination compound, this coordination entity is carrying a negative charge, that is 3 minus charge. So by using these two, we can calculate the oxidation state of central metal ion here. So the unknown charge we have taken as X plus 3 oxalate ions, each carrying 2 minus charge. So 3 into minus 2 is equal to the overall charge on the coordination entity is minus 3. So X plus minus 6 is equal to minus 3. Therefore, X is equal to plus 3. So we have got the oxidation state of central metal ion, that is in plus 3 charge. Now we have got all these needed things, so we can start naming it. We have 3 oxalate ions, so we will start naming with trioxalato. Ion is here, but this coordination entity is an anion entity, that is, it is carrying a negative charge. According to the rule, if it is an anion entity, we have to use the suffix ate along with the central metal ion. So we will write trioxalato ferrate and oxidation state 3. It is an ion carrying a charge, so ion. This is the name of the given coordination entity. Let's see one more example. Write the IUPAC name of the given coordination compound. So the coordination compound given is CONH3 6 times Cl3. So the first thing is to sort out the central metal ion. You know that is cobalt here. And once you know the central metal ion, next step is to calculate its oxidation state. Here it is very easy to calculate its oxidation state, since you know there is only one ligand, and that ligand is a neutral ligand, and so neutral ligand means it's carrying only a 0 charge, it doesn't have a charge. And then there is a counter ion. This is a counter ion, what is outside the coordination sphere or coordination entity. Cl is having 1 minus charge for each Cl ion. So 3 Cl ion will have 3 minus charge. So the the central metal ion will have the oxidation state 3 plus. It is understood. So it's very easy. Now once you know the oxidation state of central metal ion, we can start writing the name. Here we have only one ligand, so it's very easy. 6 ligands are there. So hexaamine, name of the ligand, hexaamine. Next is cobalt, hexaamine cobalt 3 chloride. Chloride is not part of the coordination sphere, so we can write it like this, chloride, hexaamine cobalt 3 chloride. That is the name of the given coordination compound. It's very easy, right? This is the end of our session today. I'll come back in the next session with more examples for us to name the coordination compound, because it is very important in the point of view of exam. Thank you. Thank you very much. See you again.